In my previous video, we looked at the monthly number of UFO sightings reported to NUFORC, the National UFO Reporting Center. This is a fascinating time series with multiple change points, seasonal behavior. It was great to look at. In this video, I want to examine certain predictor variables to see if we can use them to accurately track the number of reported UFOs. And there are two predictors of interest that we'll consider in this video. First, the spread of internet access across the US, and secondly, solar sunspot cycles. It's going to be a really good time. So, let's look at the data. For this video, we're going to look at the same NUFORC time series as last time, but instead of monthly, we're going to consider annual UFO reports. The reason for this is one, to remove seasonal fluctuations, which our models are not going to be able to detect or predict. Also because the internet coverage data was only recorded annually, and thus it's at a much coarser resolution than our other data sets. We'll also only consider 1990 to 2019 because that's where the data sets got cut off. After aggregating the NUFORC data over each year, we see the same trend that we found in the last video. That is, there's a gradual increase from the start in 1990 to about the mid-2000s. There's also a spike in reports from about 2011 to 2015, and there's a final jump in reports around 2019 and 2020. In contrast, we can look at the percentage of US households with internet access as tracked by the World Bank. Here, we see a steady increase from the mid-90s to around 2005, which is similar to what the NUFORC data looks like. So there's a good chance that we'll be able to use this for prediction purposes. For a more intriguing predictor, the number of sunspots has been tracked for hundreds of years. There are long 11 to 12-year cycles in this data set. So I'm not an astrophysicist, but roughly speaking, more sunspots means more solar activity heading towards Earth. And there was a Reddit post a few months ago that sort of piqued my interest in this. The claim was that during a solar storm, we should go out and, look for not auroras, but UFOs, because the increased radiation may tamper with their cloaking mechanisms on their craft. All right. That's a bold claim, and I really wanted to see if there is any evidence in the data that increased sightings could be linked with increased solar activity. In our timeframes of interest, sunspot counts are actually decreasing through the early 90s, then they increase until about 2001, they drop again until about 2008, hit another peak around 2014, and then drop again as we move into 2020, where the dataset cuts off. Let's put all this into a statistical model and see what comes out. When working with counts data, it's useful to use a tool called Poisson regression. Poisson regression considers the response variable, in this case, the number of annual reported UFO sightings, to have a Poisson distribution, conditional, that is, on the predictor variables that we include in the model. For a Poisson random variable, the mean is equal to the variance. So if the rate of occurrences increases, so does the variance of occurrences. And this is exactly what we saw last time in the NUFORC data. In the 90s, we had a very low rate of reports, and we also had a low variance month to month. But by the 2010s, the rates and the variance were much higher in this dataset. Following from the change point analysis video, I split the data in half to fit a Poisson regression to the 1990 to 2003 portion of the data, and a second Poisson regression to the 2004 to the 2019 portion of the data. The reason for this is that it's very likely that more than one model will be necessary when looking at data over a wide time span. I mean, things change and we need to model them differently. After some model selection, I tried to predict UFO reports by a quadratic model in the percentage of internet access and a linear model in the number of sunspots. I also technically used an over-dispersed Poisson regression, which is a Poisson regression with an additional dispersion parameter. This allows for larger variances than the standard Poisson regression would account for, and it's really useful when you're doing statistical significance testing. Regardless, putting all of this into R for the first half of the data results in, well, a strongly significant effect for internet access. And no, statistically significant effect for sunspots. The internet access equation is a quadratic with a negative coefficient in the squared term. What this means is that the number of UFO reports, technically on the log scale because we're using a log link function, appears to be increasing as internet access increases, but it's increasing at a decelerating rate. And this intuitively makes sense. As we can only get to 100% internet coverage, as we approach this upper bound of saturation, the effect is dampened. Once we get to 70, 80%, it's not making a huge difference when more people get the internet. For 1990 to 2003, I have to conclude that the spread of the internet was the dominant factor driving the increase in UFO reports. This doesn't mean that there were more or fewer UFOs in the sky, but mainly that it was becoming much easier to figure out how to report one if you happen to see it. By 2004 or 2005, internet access across the US had stabilized to about 70 to 75%. What happens if we fit the same model to the data from 2004 to 2019? Well, we get a weakly significant internet effect and a strongly significant sunspot effect. The model predicts that for every additional sunspot looking at Earth, the number of reported UFOs should increase by about 0.5%. Now that sounds small, but let's think about that for a moment. Since the number of sunspots jumps from around just above 0 in 2009 to over 100 in 2014, the model predicts an increase of about 75 to 100% more UFOs reported. And that's exactly what happened. In 2009, there were 5,010 reports, but by 2014, there were 8,741 reports. That's really cool. And I'll be honest, I did not expect to find any significant effect for sunspots, so I'm really excited that I did. Another way to look at this is to plot the predicted number of UFO reports with the actual number of reports. If we try to only use internet coverage as a predictor, the model does a really poor job at fitting the data past 2005. Instead, when we include sunspots as a predictor, we clearly capture that peculiar spike in reports that occurs between 2012 and 2015. The only thing our model isn't really able to predict is this final increase or spike in reports around 2019. At that point, sunspots are going down, and the internet has roughly stabilized. It's roughly constant, but there's still a big spike in 2019, which is peculiar. Now that statistics and mathematics have fit this nice model for us, we have a tough challenge, and that's interpreting it. I can really confidently say that prior to 2005, the rise in the internet was really the dominant driving factor in the increase in UFO reports, which was strong enough to block out really any other factor. But once the internet coverage had stabilized, we can look for other predictors. The fact that the spike in sunspot counts precisely aligned with the spike in UFO reports makes me very excited. I did not expect to see that. But we still have to consider, why is this the case? We could always say, oh, well, correlation does not imply causation, but that's really a lazy cop-out in my opinion. The hardest part about this interpretation is that we don't know what the major source of the New Fork reports is. We just know that the reports have gone up. What I mean is that, are most of these reports coming from boring things in the skies like drones and satellites just cruising by? Are they coming from actual extraterrestrial craft that we're witnessing? Are they coming from weird atmospheric phenomena like whatever ball lightning is? Or are they coming from something else like mass hallucinations, if that's a thing? Personally, I think it would be awesome if the answer were aliens. I mean, that's what we all kind of want, right? But let's consider each of these and ask, how would sunspots make sense under each of these scenarios? For mundane craft, would an increase in solar activity make them appear spookier or more visible? I mean, I don't know. I don't see why, but I'm not sure. For ETs, would sunspots affect their craft? Now, this is pure speculation, because if there are ETs, we don't even know what their crafts are, but I have to assume that nothing is going to 100% block out high-energy radiation coming from the sun, so the Reddit claim might actually have some merit there. For atmospheric phenomenon, we know that solar activity causes auroras, so it's not out of the realm of possibility that it may also cause other inexplicable things that we would see in the sky. And lastly, for hallucinations, does increased solar activity affect our mental states? No idea, but it would be interesting to investigate. The data I have is not going to answer any of these questions, but they are all possible follow-up investigations, and I think regardless, it would be really cool to follow up on this. I mean, if we believe that this simultaneous spike in UFO reports and sunspots is actually causal and not just coincidental, then there's a lot more to investigate here. So what's next for this data? Well, we've looked at temporal characteristics in the last video. We looked at some predictors in this video. Next, I really want to look at the data from a spatial perspective. That is, where in North America are these sightings being reported with the highest frequency? That analysis, I'll be honest, is slower going because the data is really messy, and it takes a lot to sort of clean up each of the individual entries. But stay tuned for that video in the near future, because it will come eventually, and thank you, as always, for watching.